Hi everybody, in this video let's do some revisions on algebraic expression. Now first we need to know what are like terms, what are unlike terms. So for like terms, they have the same variable and the power of the variable are the same. The power of the variable are the same. Okay, let me give you some example. Now, let's say I have two terms. One is 3xy squared, and another term is negative 2 over 5xy squared. When we want to determine whether the two given terms are like terms or unlike terms, we only focus on the variable part, this part. The coefficients, negative 2 over 5 and 3 is not important. Okay, now remember, same variable and the power of the variable are the same. Now the variable here is x and y. The variable here also x and y. They have the same variable, but are their power the same? The power here is 1, the power here also 1. So for the part x, same power. So how about y? The power here is 2, the power here is 2. Therefore, we can make a conclusion that these two terms are like terms. Now, how about 4x squared y? And the terms is 0.3x squared y. Are these two like terms? So when we want to determine like terms or unlike terms, we only focus on this part, the variable part. So 0.3 and 4 are not important. Same variable, x and y, same is also x and y. The power of x here is 2, the power of x here also 2. So the power of the variable x are the same. How about y? The power here is 1, the power here also 1. So therefore, these two terms are like terms. Okay, so now let's look at this one. 2 over 5xy squared and 5x squared y. Are these two like terms? They have the same variable, which are x and y. Now the power of x here is equal to 1. If you don't see any power here, it means the power 1. Okay, now the power here is 2, different power, right? So the power of y here is 2, the power of y here is 1, different power either. So in this situation, we say that these two terms are unlike terms. Okay, so why is so important for us to know whether the two terms are like terms or unlike terms? Because only like terms we can add them together or perform subtractions. For unlike terms, we cannot plus or minus. Now let me give you some other examples so that you know better what are like terms, what are unlike terms. Okay, now let's go through this few more examples so that you understand better what are like terms, what are unlike terms. For like terms, I will put a tick. For unlike term, I will make a cross. Okay, 4xy and negative 0.5xy. Ignore about the 4 and negative 0.5, they are not important. We only focus on the variable part. So this is xy, this is xy, and the power of x here 1, the power of x here 1, the power of y here 1, the power of y here also 1. So these two terms like terms. Okay, now how about this one? As I told just now, forget about the coefficients. Negative 3.5 and the square root of 4 are not important. Now the x here is power x power 2, x power 2, y, like terms. Okay, same variable and the power are the same. This power 2, here also power 2, this power 1, here also power 1. Okay, like term. So how about this one? X squared, 3x squared y, 5xy squared. Now they do have the same variable, which is x and y, but you need to be more careful. The power of x here is 2, but the power of x here is 1. The power of y here is 1, the power of y here is 2. Therefore, these two are unlike terms. Okay, now how about this one? So as I told you just now, forget about the coefficients. 2 over 5, 6, we can just ignore them. We just focus on the variable part. So x, y square, z. X, y square. Different variable, right? We have x, y, and z. Here we only have x and y. Okay, therefore these two are unlike terms. The power of x here is 1, the power of x here 1, the power of y here is 2, the power of y here is 2. Same power, but different variable. We have z over here, we don't have z over here. So these two terms are unlike terms. Okay, now this one you need to be more careful. So some students might be thinking these two are like terms because we have a variable x, here also variable x, and here you see no power written here. Is power 1. This is power 1. Therefore, we make a conclusion that these two are like terms. This is actually not correct. 6 over x is actually equal to 6 times x power negative 1. You are going to learn this in the future. Okay, so actually they have different power. So this is 6x power negative 1. This is 2x. Same variable, which is x and x, but the power here is negative 1, the power here is 1. Therefore, these two terms are unlike terms. Okay, let me explain a little bit more about this one. Now, 6 over 2, right? This is actually equal to 6 times 2 power negative 1. Let me show you by using my calculator. 6 divided by 2, you know the answer must be equal to 3, right? How about when I key in this one? 6 times, okay, I just put a parenthesis, 2 power negative 1 is equal to 3 as well, right? This is also 3. Okay, so be careful. When the x here is at the bottom, at the denominator part, and this is actually the numerator part, their position are different. So in this situation, the x is actually power negative 1, the x is power 1, different power. Therefore, these two terms are unlike terms. Okay? Now, how about this one? So you might be thinking these two are not the like terms because the x here is at the top of the fraction as the numerator, and the x here is at the middle of a fraction, but they are actually like terms. Okay, 2 over 3x and 2x over 3. I cannot say that they are exactly the same. This is 2 over 3 times x, this is 2 times x over 3, but these both having exactly the same value. Now you can take out your calculator and take a try. Now let the x be 2. Okay, I just let the x be 6, for example. Try to press your calculator. 2 over 3 times 6 compare with the 2 times 6 over 3, or we can just do it without using our calculator. This one I think should be no problem, right? So simplify it. Divided by 3, 2, you will get 4. So this one divided by 3, you get 2, you also get 4, right? So this both having exactly the same value. Okay, so don't get confused. This and this, they are the like terms. But you have to be more careful. This is equal to this, they have the same value, but it's not equal to 2 over 3x. You can press your calculator if you let the x be 6. 2 over 3 times 6, you will not get 4, right? This is 1 divided by 2 divided by 2, divided by 2, 6 divided by 2 you should be able to get 3, 1 over 9. You see, when this is 6, this is 6, this is 6, these two give you exactly the same value, which is equal to 4, but this one gives you different value, which is equal to 1 over 9. Okay, let's try two more. These like terms, same variable, and the power is here is 1, 1, like terms. Okay, how about this one? These two like terms? No, unlike terms. This is actually equal to 1 over 2 times x to the power of -1, because this is the x here is at the denominator part. Okay, so I think after watching this video, it should be no problem to differentiate whether the two given terms are like terms or unlike terms. So remember, like terms, same variable, and the power of each variable are the same. Okay, that's all for this video. See you in the next video. Bye bye.